We initially discussed that there are two groups of process charts. The first group of charts was the one in which we draw the sequence of operations without drawing them on time scale. So we discussed outline process chart, flow process chart, swim lane chart, and two-handed chart. The second group of process charts are those charts which record events in the sequence in which they occur. So that is common with the first group. We show the sequence of events, but we draw them on a time scale. So that is the difference. So that the interaction of related events can be more easily studied. Charts falling in this group are three: multiple activity chart, standardized work combination table, and SIMO chart. First, we will discuss multiple activity chart. Multiple activity chart is a chart on which the activities of more than one subject are each recorded on a common time scale to show their interrelationship. What is meant by more than one subject? So we might be simultaneously charting worker and machine. So a worker is operating a machine. So we can use multiple activity chart. Or it could be, for example, two workers who are working on the same machine. One is loading and unloading the job, and other is, for example, performing the operation. Or it could be one operator operating two machines simultaneously. Of course, if they are semi-automatic machines. So there are two types of multiple activity chart. One is what we call worker machine chart and the other is gang chart. So first we will have a look at worker machine chart. So the worker and machine process chart is used to study, analyze and improve one workstation at a time. The chart shows the exact time relationship between the working cycle of the person and the operating cycle of the machine. So we can see when the worker is busy and the machine is idle, and when the machine is busy and the worker is idle, and we can calculate their utilization. So these facts can lead to a fuller utilization of both worker and machine time and a better balance of the work cycle. The bottom of the chart shows the employee's total working time and total idle time, as well as the total working time and idle time of each. Generally, we chart for two things. One is the idle time and other is the working time. And we can actually divide the working time into further categories if it is required. But at least two categories are there: idle time and working time. The productive time plus the idle time of the worker must equal the productive time plus idle time of each machine that the worker operates. So that is very important, that total cycle time should be equal. So total cycle time should be equal. So sum of the idle time and working time of the worker should be equal to sum of idle time and working time of the machine. This is not exactly a worker machine chart, but just to give you an idea what is shown in a worker machine chart. So we have a worker that is operating a drilling machine. So this is what the worker does. So he picks a piece, places it in a jig, clamps the workpiece in the jig, lowers the drill, throws in feed, and so on. And time taken is half minute. But during this half minute, the machine is idle. Then once machine is ready, the worker is idle and we drill half-inch hole in piece using power feed. So worker is not doing anything because the hole is drilled using automatic feed. And this operation takes 2.5 minutes. And then the worker performs certain activities. He raises the drill, removes the workpiece and so on. And it takes 0.75 minutes. So during that, machine is idle. So you can see this half minute plus 0.75 minutes is the working time of the worker, and this is 2.5 minutes is the idle time of the worker, and vice versa. So idle time of the worker is this 2.5 minutes, and his working time is half plus 0.75, this 1.25 minutes. So total cycle time is 3.75. It is just the opposite for the machine. So total cycle time is the same. And working time divided by total cycle time is the utilization. So we can see that worker is only 33% utilized. So these are the times that we have used for the calculation. So we can further utilize the worker because he is underutilized. Here is another example. Here we have one operator and we have two machines. So worker is operating two machines. And once again, I would recommend to mention these details or similar details whenever charting a process. So name of the operator, name of the operations department. Here we have used this solid line for the operation and this dotted line for loading and unloading. So here we have got similar details, the idle time for machine, the productive time and so on. But you can use, of course, different symbols as well. You can use uh, some rectangle or hashed lines as well. But in this case, the solid line showing operation, dotted line is showing loading and unloading, and nothing drawn, just like here. A blank area is showing the idle time. And we have drawn these times according to scale. That is very important to keep in mind that these time values are drawn according to scale. So that should be kept in mind. So here we had one operator and two machines. And this is a better template and I would recommend you to use this one whenever drawing the charts. So apart from the details in the header, in this case we have one operator, one helper and a machine. And here the running time or activity time is shown as this hashed line or hashed rectangle. Waiting is shown as this filled rectangle. In this case, you can see here and here and here. This is waiting. So first there is the description of the activity, then the time is written, and then that time is drawn to scale. So description of the activity, amount of time, and then this bar is drawn as per scale. Waiting time, description of the wait, the waiting time, and then that time is drawn to scale. Or for example, prepare wrappers and labels, that is the name of the activity, the time it takes, and then that time is drawn to scale. And then in the end, we can add up the idle time for operator and from the above chart and calculate the working time and divide the two, that is the working time divided by total cycle time gives us the utilization. Same is true for helper. So working time divided by total cycle time is utilization of the worker and same is for machine. So you can notice that denominator is the same, 5.2 minutes, because we are drawing for one complete cycle and total cycle time should be equal in all cases. So this template is relatively better and I would recommend you to use this for your assignments. This is important that accurate elemental time values are necessary before the worker and machine charts can be constructed. So these time values should represent standard times. It is recommended that you use standard times, not simply observed times. We should add allowance in drawing, uh, in finding the standard time to draw these charts. We will see how we use those allowances to calculate standard time in the next module. But you should keep in mind that the time mentioned in worker machine chart should be standard time. What is the usefulness of this chart? The completed worker and machine process chart clearly shows the areas in which both idle machine time and idle worker time occur. So wait is an important waste, so we can easily target that. We can easily identify that and then reduce that using this chart. These areas are generally a good place to start in effective improvements. However, the analyst must also compare the cost of the idle machine with that of the idle worker. So let's analyze whether it is less costly to keep the worker idle or to keep the machine idle, because there will be some idle time in either case. It is only when total cost is considered that the analyst can safely recommend one method over another. So you have to keep other factors in mind when comparing idle time of the worker and idle time of machine. Now, one variant of this multiple activity chart is gang process chart. So in this type of chart, we don't have actually any machine, but a group of workers working together. So this chart tracks the activities of two or more workers performing together as a team. So there is no machine as such that they are operating. The purpose of gang chart analysis is to better coordinate the activities and balance the workload among the workers or to avoid mura between different workers. So this is an example of a gang process chart. So in this case, we have four people in the group: electrician, fitter, rigger, and process worker. And each of them is performing certain activities. For example, electrician is removing heaters and he is doing this activity. And then you can see the same for fitter, what activities he is performing. And you can see that we have drawn these activities to time scale. So this length, this height should be according to a time scale. Now you can very easily see that for this one complete cycle, the rigger is relatively free. He has a lot of free time. Same is true about process workers. So we should think why he is free, why he is not doing anything, or how we can utilize him. But as a whole, electrician is much busier and fitter is much busier as compared to rigger and process workers. So this chart can be used when a group of workers is working together, just like material handling workers, if they are loading and unloading some heavy um, goods or material together, we can use this chart there as well. So this is a special form of multiple activity chart.